Okay, welcome to Rakuten Technology Conference 2014. Now we will start the session Ichiba Architecture on ExaLogic. Please welcome Watanabe-san and Gon-san. Please.
Thank you. Good afternoon. Thank you for attending our session. My name is Kwon. We introduced the ExaLogic system on Japan Ichiba in 2013. In this session, I would like to talk about Ichiba architecture on ExaLogic. Let me show you the structure of ExaLogic. This presentation consists of 5 chapters. It's about the Ichiba architecture on ExaLogic from chapter 1 through 4. And chapter 5 is about ExaLogic operation on all major. At first, I will give a presentation about ExaLogic architecture, and Watanabe-san will give a presentation about ExaLogic operation on all major. So let's start our presentation. The first chapter is introduction of ExaLogic. Rakuten Ichiba is #1 e-commerce website in Japan. This is the top page of Japan Ichiba. It seems like a single page, but actually our pages consist of many services. And if you can see the backside of our system, you can find that many services are associated with another services completely. For constructing service, we have to prepare many components. For example, we need to construct servers, database, middleware, and business application. And each component must connect each other via network. If a service is started, we have to do maintenance for each component. Most of service companies are maintaining massive systems for providing many services, and many engineers will be needed for operating our massive system. Everything was prepared perfectly, but sometimes we notice that the system can't be operated effectively. The reason is that most of services have different peak time. In the same time, both low load and high load service are existing, and high load service cannot use resources of low load service because each service is using different system. If you can do servers more effectively, and if system can be operated by 4 or 5 persons, it will be a great thing. So we have decided to introduce the ExaLogic system on Japan Ichiba. ExaLogic is the engineered system manufactured by Oracle, and it is customized for Fusion middleware software such as RakutenTechConf2014 and Coherence. This is the specification of ExaLogic. As you know, ExaLogic is a very powerful system, and ExaLogic is including operating system, managing software, and Oracle Traffic Director. Oracle Traffic Director is very important software for Japan Ichiba. Please remember OTD. I will explain about OTD later. Anyway, our plan is to migrate Japan Ichiba from legacy system to ExaLogic. Our target services are about 50 services and operated by 400 servers. We are expecting to down operating cost and realize non-such system by introduction ExaLogic. The second chapter is about middleware architecture on ExaLogic. Oracle Traffic Director is located on front side for forwarding requests to application servers such as WebLogic. As everyone knows, WebLogic server is used as a web application server. Actually, requests will be processed at WebLogic server. And optionally, coherence can be located between WebLogic and database. Coherence will be used to cache server for physics object or session data. Also, all the servers will use Juniper server for real-time monitoring. If you don't know Juniper, don't worry, I will explain it later. OTD is load balancer software. OTD has access information to each service. All requests on ExaLogic are only processed via OTD. WebLogic server is part of Fusion middleware software. Our applications will be deployed on WebLogic server, and we are supporting 11Z and 12C for ExaLogic. Coherence is Java-based data grid software supporting in-memory access. Usually, Coherence server has data access object, and stored object in Coherence can be updated to database later. This function is called write behind. We can improve our application performance dramatically by using write behind function. And you are supporting 12C for Coherence on ExaLogic. Juniper is the real-time monitoring system introduced to Japan Ichiba in 2012. This is the dashboard of Juniper server. If the Juniper server is connected to the application server, we can always monitor all processed requests on all servers. From next slide, I will explain about system design on ExaLogic. We have considered 3 keywords while designing system architecture on ExaLogic. These are automated, standardized, and non-stop. Our system scale are expected to grow in the future, and our goal is to have this big system manageable by 4 or 5 persons. Automate and standardize are essential requirements to reduce operation. And at the same time, we have to guarantee the non-stop system. All of system designs on ExaLogic are based on these 3 keywords. ExaLogic is providing GFS appliance of 60 terabyte. So we have decided to use GFS storage for every applications and data storing. We have created 2 shells for application and data, and we have mounted shells to every computer node. If we need additional computer node, we can start instance on additional node by mounting shells, because all of installation, data, and operation tools are existing in shells. We are using the Infiniband network for communication between computer node and GFS appliance. It's very fast, like a local disk. All of servers are sharing resources such as middleware installation, domain installation, library, and configuration. And server also need a private resource such as log files, application data, and managing data for each instance. These resources need to have separate paths. If resources are not separated, it will be the bottleneck. We are using variables having instance name to separate resources. And we we must control not to duplicate server resource such as port number and IP address, because ExaLogic is sharing a server resource for all applications. So we had designed rule-based application for using not duplicated resource. We have created operation tool for auto construction. And if you want to construct application, we need to decide only two parameters. It's application name and number as an indicator for application. If our construction tool knows only two parameters, application will be constructed automatically. One of our most important things is a floating IP for operating application server on ExaLogic. Each WebLogic subdomains is using different floating IP zone, and floating IP address, for instance, is predefined on configuration of WebLogic domain. Floating IP address can be moved to the another computer node by online. As a result, if instance has a problem, we can simply migrate WebLogic instance to another computer node. And we can migrate server by one command in 2 or 3 minutes. Legacy applications have one problem. Most of legacy applications have the different environment. Many applications are using different versions of middleware, variables, and customized script. So we need the education cost for running legacy applications. Accordingly, we feel the need of standard environment. So we created a standardized script set for all applications running on ExaLogic. This script set can control WebLogic and Coherent server remotely, and when Juniper server is installed, it is designed to start monitoring automatically. As a result, our applications have same script set except option configuration file, and we can control all application servers remotely by using the same command. But as everyone knows, Node Manager is used to control WebLogic server remotely. If WebLogic instance is started by Node Manager, standardized script set will not be used. But we know that the Node Manager can be customized by editing property file, and we have combined Node Manager with our script set. So we can use anything to control WebLogic server. WebLogic will be maintain the same environment. Our main focus is constructing non-stop system. Until now, our legacy system is used to stop when doing system maintenance. The important thing is to remove downtime. We need to know some function of OTD to make non-stop system happen. For processing request, OTD needs configuration having port number and application server information. Port number is called listener, and application server information is called origin server pool. And OTD will forward request to application server based on configuration. For each service, we need to associate access port number and application servers, and listener's origin server pool can be changed dynamically. So we have defined two listeners and origin server pool on OTD for each service. And we have constructed two WebLogic domains for our application in order to connect origin server pool. As a result, listener can connect to the A or B domain by switching origin server pool. Now, we can release and test to the application at the tester domain in advance. And we can make non-stop maintenance possible by switching origin server pool of listener. The good point is that we can test the application on production environment before service release. When we decided to introduce this design, we didn't know that the concept already existed. It is called the blue-green deployment. The effect of using blue-green deployment was very successful. In case of our first migrated application, release time was reduced from 6 hours to 20 seconds. But if our application is session pool, session data will be lost when switching application. For resolving this problem, we constructed coherence cluster including 2 WebLogic domains. Session data will be stored in coherence cluster, and WebLogic domain can access the session data by using coherence web. We can solve the problem by sharing session data to the coherence cluster. Now we know to make non-stop operation possible, we need 2 domains, and also we know that Juniper server is necessary to monitor WebLogic domains, which means that we need 4 installations to construct service. For legacy environment, we needed 1 or 2 weeks for construction. We wanted to cut construction time on ExaLogic, so we have created a tool for automatic construction. A tool is constructing application by using template, and required information is only application name and number for construction. Now by automating, we only need 5 minutes to construct service. I have explained the concept of system design on ExaLogic. Let's move on to the next chapter. Next chapter is on application lifecycle on ExaLogic. All applications on ExaLogic have same lifecycle. A lifecycle has 4 phases: release, testing, switching, and operation. First phase is an application release. A rule for application release is that release material has to keep same directory structure with production environment. We can release any applications by keeping this rule. If you use Maven, I would like to recommend the assembly plugin. When building an application, Maven's assembly plugins can deploy files to predefined directory. After preparing release material, it will be moved to release history directory. And we can release files to standby domain. Release task is executed by release recipe automatically, and only new or modified resources can be updated. Recipe is an executable release document. I will explain at chapter 4. This is the workflow of release recipe. If application is already installed, we are always removing all the application, and after restarting WebLogic domain, new application will be installed on WebLogic domain of clean status. Next page is testing. I have explained that we can access standby domain via listener for test. If application has been released, we can always access to application from internal. It is the big benefit to test the application in production before servicing. In test phase, application can be updated many times over. So we can fix the problem of application before switching application. If the test is finished, upgraded service can start by switching application. Service can be switched without stopping. Movie on top is the dashboard of current service domain, and bottom movie is the standby domain. If we switch domain, all requests will be moved to standby domain. After switching, standby domain will be new service domain, and old service domain will be standby domain. After switching on application, release material needs to be renamed to the name, including switched data, and this directory will be linked to directory for operation. Release material and production environment will direct to the same point, and linked directory will be used for operation of the production environment. Now, we need to operate the production application. When the application raises some problem, it needs to be rolled back previous version. If standby domain is not updated, it will be returned to previous version by switching application. In this case, we can change application in just a few seconds by using automated recipe. But if the application is already updated, we need to deploy the application of previous version to standby domain. For this situation, we are storing release history. We can deploy application to standby domain by using release material of previous version. As a result, we can switch to the previous application in 5 minutes by one command. Service doesn't stop in any case. Normal operation means to update configuration of production application in real time. For normal operation, we are using list material existing in the operation directory. At first, we will update configuration file of list material, and the configuration files will be updated from operation directory to production application. So the operation directory is always maintaining at the latest status. My last chapter is about cost-effective operation. WLST is command-based tool for WebLogic. We are using WLST commands for controlling WebLogic domain on ExaLogic. It's a good solution for automated operation because of the operation recipe can use WLST command. Release document is a list of OS command for release operation. For the legacy system, we are doing release operation by cutting and pasting commands from the release document manually. And For every maintenance, we have to update release document because most of applications have different environment. It was a reason of high operating cost. But for applications on ExaLogic, operations are standardized and can be covered by one release document. We are calling it operation recipe. Most of ExaLogic operations are done by this recipe, and we are using only 3 operation recipe: construction, release, and switching. For more effective operation, we made trigger system. Trigger system is auto execution tool for operation release recipe. Trigger system can select mode with the sequencer and automatic execution, and we can register trigger as a job of Jenkins. In this case, we can execute operating task on web browser. This is a demo video creating application using trigger. In this demo, we are creating 2 ExaLogic domains and 2 Juniper servers. To create the application, we have to input some arguments. There's a application name, number, ExaLogic version, and our construction recipe. Then our recipe will start creating application. ExaLogic and Juniper server will be created by using template. As you see, after installing servers, recipe is using wlst and shell command to update server configuration. And all configuration steps are printed in console. In case of Juniper, we need to define many ports, and we have to make sure not to complete port for all servers. It's done automatically by our recipe. By using this trigger system, we reduce the operating time extremely. This demo is played in 8x speed, so actually it's taking about 5 minutes. When our construction recipe is finished, our server is already started. So if we have list material, we can deploy application right away. Next chapter is about ExaLogic operation on OS major. Watanabe-san will give a presentation.
Thank you, Go-san. Hello, everyone. I'm Yu. I'm working also for ExaLogic organization with Go-san. And I'm going to talk a little bit more in everyday operations. He's more on installation and releases. I'm more on everyday operation. Okay. First, what's Sales Manager? I guess most of you never heard of this before. Well, don't worry, you shouldn't, because this is a scratch built application management tool that we made. So, and we never introduced this to the world, so you should know. Okay. Okay, next question is, why scratch build then? There's a lot of cool tools around the world, and there's Oracle Enterprise Manager, which is the standard for the ExaLogic, but we didn't choose this. Okay, why? Because we're Rakuten Ichiba. Okay, how's Rakuten Ichiba? We have lots of teams working on it, applications, instances, and releases. More than 30 engineering teams working on this Rakuten Ichiba, and which makes a team reliant operations. So every team has their own goals, judges, and procedures to follow. So if you move from one team to another, if you have to learn everything all over again. And we also have 150 applications, more than 150 applications running. So it makes everything scattered. So things are there, everywhere, and all messed. So it's hard to know which server or which language this is running, and a lot of things you have to know. We also have more than 3,000 instances totally, so which makes access alert mail. Some applications running like hundreds of instances, so if they have a trouble, each one of the instances was throwing alert mail before, and more than we used to get 10,000 of mails on trouble, and because of our nice PHS, we could only receive 700 of mail, so we have to receive and delete like 15 times to clean everything. So sometimes the important mail was buried somewhere. And we also have more than 1,000 releases in a year, which makes high trouble risks. But we can reduce releases because this is to keep attractive service. And each release is sometimes bug occurs and human error happens. So what we needed was to standardize the basic operations so we don't have to know which application and to operate. And also we need to integrate and portalize management tool so we don't have to know where the resources are. And also collect log and pack alert mails, well, to stop vibrating my pocket. And also to simplify and clarify for the fast detection. That was things we needed before. So that's how Oz Manager was born. And okay, let me start introducing a little bit about Oz Manager. I'm going to show you some video demonstration later. Before that, I'm going to explain a little bit about Oz Manager. Okay, this is a brief system configuration with operators access to the Oz Manager, and you don't have to know what kind of monitoring tool you have or service application you have behind. Oz Manager has a plugin type of control, so if you access Oz Manager and do some operation on backyard, Oz Manager will give a control to monitoring tools, log collection tools, and service applications. And these are the configuration for the plugin we have. It's pretty simple. We only have 4 types of plugin. Checker for the monitoring tool, log collector, application, and others. First 3 is fixed interfaces. And we made it simple only to stop, start, and change settings and get states. And for the application, we can only stop or start and get status. And for the other, this is for the special users. If you want to have a convenient tool, convenient way to use, you can add it on the other plugin. And these are the one we actually have right now. We have Nagios and Pandora for the monitoring tools. Log collector, this is also a scratch build collection tool we have. And some application we're controlling. And for ExaLogic, we have a special tool. We will show you this on the demo later. And okay, so this is a data relation example. On top, there's a components we have. Cluster, application, and host are the components we have, and they're all related to each other. And each one of these components have a control group to relate checkers, links, and log collection, and other control plugins. And for the authentication and authorization, we have a user joined to one or more user groups. And each user group has an authority to control whichever cluster is related, and some menu you have. I think you can understand on the video later how this works on the video. Okay, these are the checks we're doing for the ExaLogic. For the cluster, we have a group of application. For ExaLogic, we have a service domain A and B and the coherence. We're checking the log, which is collecting all log to one place and checking to reduce mails. And for the application, we're checking the processes for each application, each instances. And WebLogic instance, for the WebLogic instance, we have a special checking for ExaLogic. We're checking if the instance is online on OTD balance or not. So we exactly know if this instance is up and also used for the service. This is special for the ExaLogic. We're also checking the host for normal resources, and we have also the burst process. This is also special for ExaLogic. This is checking if the compute node has any burst process, because in ExaLogic you have a lot of instances and different instances running on one node. So sometimes one process might get burst and give an impact to others. So we have to know exactly if you have any burst process. Okay, let's move on to the demo. Okay, this is how Oz Manager looks like. On the left side, there's a component explorer. You can click them, and you can see the detail on the right side. And you can see all the related controls, like checkers, log collects, the one I was showing before for the data relation. And you also have links to jump onto your WebLogic admin or Jennifer server, the one Pon-san was talking about. And you don't have to remember all those links. And you can add those from each component. Before that, you have to log in. This is for the authentication. Once you log in, you see these new menus showing up. And for each one, you have editable ones and non-editable ones. That's because you have authority to control only the ones you are joining for the group. So let's say this user can control this ExaLogic system. So now he has a button to stop, and all the commands you can do to stop and start checker or change settings here. Oh, these are the commands you can control. And also you can edit from, now you have the pencil. Oh, it didn't go. Okay, this one is a real-time status. You can see. Oh, you can see the detail of the log, what's going on. This is collecting all the logs and counting the numbers, how many errors they have. And you can also list those in one page using dashboard. So sometimes we're using this for supercell and stuff like that. When we have an event, someone have to sit and watch if you have any problem or not. This one will automatically add another row in every minute. And whenever something gets wrong, you see the red sign or yellow sign on it. And we also have a way to a report page. You can select a period, when to when, and you can see the graph, how the status move up and down, and also the summary data, the total number, the peak time, and so on. You can see these numbers. Okay, next one is the monitoring tool. No, not monitoring, it's a maintenance tool. This is used for, we have a maintenance every month, and sometimes our system have to be stopped because of the network maintenance or database maintenance. So what you need to do is to stop the monitoring, because if you stop the network, there's going to be a lot of errors, or you have to stop the server. So what we do is we have a list of applications added in us. What we do is set a flag for monitoring switch and application switch. Okay, on this time we want to stop node managers, monitor, and this order RB's application instance. And for the maintenance day, you just go to the monitoring switch, and you can see all the applications you check, and you can see all the checkers for this application. You have like a whole bunch of checking. All boxes here are one checking. So if you stop them, you can stop everything in one shot. So you don't have to. So you don't have to have every team sitting and stopping their own application. You only need one person to stop everything at once. You can also do this for the application instance. This one is stopping 2 applications. This will actually stop the WebLogic instance behind. And what cool thing about this is it doesn't have to be it doesn't have to be the same application. It can be WebLogic, Tomcat, PHP, Apache, whatever. If you have a plugin, you can stop everything in once in this page. You just have to have a plugin for each one of them, and it will automatically stops. And also you can start. Okay, you can see if you hit check status, it's starting up, and later it's going to be on green. That's how we are doing the main control on the maintenance. Okay, let's go to the next one. Okay, next one is a command line interface. There's 2 ways we can work on command line. First one is shell mode. You can log into from this Aussie client, and you can do the same thing you can do on the web list, or get status, or stop monitoring, or stop instances from here. We also have a online command also. We can add a subcommand after the command and type user and password file, which has a password inside and the options, and you can click on and do it on one line, which you can add these for the script you want to have. Like constant script is using this command to stop monitoring before releasing new material. And after the switch, it will start automatically, so we won't forget to start the monitoring. Okay. Finally, this is a special use for ExaLogic. Kong-san was saying about A side, B side, the blue-green, you can see on one page. You can get all the data with, which application is running on which side. And also we can check it on each detail. If you go on the right side, on the top right, you can see which side is running. And this is special for ExaLogic. And we also have a instance location. This we just added the other day. You can see on which host how many instances of ExaLogic is running. So you want to know which node has more load than the other. So we can move around, or if you have a bad node, you have to move those onto the other nodes, which has load. This is okay, and this is all the demonstration and the future plan we have. We're thinking of adding the switching for the diary side and instance location, the one I just showed before. So we can switch A side, B side from the web or change location, maybe drag one instance from to the other so we can move it a lot. And some ExaLogic coherence plugin maybe in the future so we can have more detailed information from JMX, show the graph and stuff like that. And many more, we're thinking to have an easy life. And so, in the future we have no more operation. That makes operation 0. And that's how the name came from. Okay, thank you for listening. We have, it's overtime. I'm sorry, I guess we don't have time for questions, so maybe you can catch us in the hallway and give us a question.
Okay, thank you very much, Mr. Watanabe and Mr. Gu.
Is it?
Yeah.
Sorry.
Thank you so much for coming.